define outcomes in S. So fixed rate, variable rate. So we will first draw a tree diagram. So first one, that will be either F, fixed rate or variable rate. So suppose it is F. Then second one will be either fixed rate or variable rate. Third one, again F, fixed rate or variable rate. Here also fixed rate or variable rate. Again fourth one, either F or V. Either F or V. Either F or V. Sorry, F or V. F or V. Similarly, if we start from V, so either F or V. So that way we can write. So what are the outcomes? If we start F, FF, 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 FV, FF, VF. I will show you the solution, then it will be clear how it is written. So suppose first one is F, second one has two choices, F or V. Again for this F, third one, two choices, F or V. Here also F or V. Fourth one for this F or V. For this V, F or V. For this F or V. For this V, F or V. Similarly, if we start from V, then we will get. This is called tree diagram. Now what are the outcomes? FF, FF. FF, FV. FF, VF. FF, VV. FV, FF. FV, FV. FV, VF. FVVV. Then similarly VFFF. VFFV. That way we can write all the outcomes. Is this okay?
Yes, sir.
Now, part B is which outcome are in the event that exactly three of the selected mortgages are fixed rate. Exactly three are fixed rate. Means there will be exactly 3F. So remaining one will be V. Exactly 3F or so 3F 1V. So what is that thing? So exactly 3F and 1V. So 3F 1V. So V will be either at the end. So fourth position, third, second, first position. So FFV, FFVF, FVFF, VFFF. That is part B. Then part C was all mortgages are of same type. Means all are either fixed rate or all are variable rate. So FFFF or VVVV. That way. Part B and part C clear?
Yes, sir. Yes, sir.
Okay. For D, at most one of the four is a variable rate. So at most one variable rate. That means there will be at most one V. So either no V or exactly one V. No V means all are F. FFFF. So not this one. FFFF or exactly one V. FFFV, FFVF, FVFF, VFFF. That is part D. Then some you have to calculate some union intersection that you can find it easily. So is this question okay? This is
Yes,
corresponding.
sir.
This is corresponding to
Yes, sir.
sample space and event. Now in section 2.2, question related to addition rule formula, subset and many other things. Basically axiom of probability. After that, addition rule for two events, three events. Those things are there. So for that, some question is done here. Only few questions I have solved. So in evening question you try to solve. And I will send you a list of problem. You solve those questions.
Okay, sir.
13. Computer consulting firm presently has. Before going to that, suppose 14 we will do first. So, suppose that 55% of all adults regularly consume coffee. So 55% consume coffee. 45% regularly consume carbonated soda. And 70% regularly consume at least one of these two products. So 55% regularly consume coffee, 45% carbonated soda, and 70% consume at least one of these two products. So what is the probability that a randomly selected adult regularly consume both coffee and soda? Then what is the probability that randomly selected adult does not regularly consume at least one of these two items? So how we can find this? Suppose an adult is coffee consume. What will be the probability? 55.55. See, that question I think done here. A is an adult is coffee consumer, B is soda consumer. So 55% regularly consume coffee. So probability of A is 0.55. 45% regularly consume carbonated soda. So P of B is 0.45. And 70% regularly consume at least one of these two products. At least one of these two means union. So probability of A union B is 0.70. These three things are okay.
Yes, sir.
Now first thing we have to find what is the probability that randomly selected adult regularly consume both coffee and soda. So both coffee and soda, that means A intersection B. So PA given, PB given, P of A union B given, we have to find P of A intersection B. So that can be find by addition rule. So P of A intersection B, that will be PA plus PB minus P of A union B, or P of A union B is PA plus PB minus P of A intersection B. From that we can find it. P of A intersection B is PA plus PB minus P of A intersection A union B. We put the value, that way we are getting the things. It is okay? Section part 1.
Yes, sir.
Then part 2 was what is the probability that randomly selected adult does not regularly consume at least one of these two products. Does not consume at least one of these two products. Then what is the event?
Sir, who does not consume anything and who consumes at least one.
No. What is the probability that randomly selected adult does not regularly consume at least one of these two items? That means does not consume at least one of the items. When means
P
consume
of A.
anything. Means consume nothing. Clear or not?
Yes, sir.
That means A union will complement. Correct?
Yes,
Or
sir.
A union B complement. So A union B complement you have to find. Or you can think this way. See, does not consume at least one of these two products. So probability of A union B complement 1 minus by complementation rule. A complement is 1 minus PA. So 1 minus P of A union B. P of A union B is given. So that way we are getting. Another way also, does not consume at least one of these two items. So does not consume coffee. So A complement. Does not consume carbonated soda. B complement. So then it will be intersection because he is not consuming anything. So A dashed intersection B dashed. That is nothing but by De Morgan's law. De Morgan's rule, it is A union B dash. That way it is done. So these type of questions may be in the exam. Okay. This question okay?
Okay, sir.
Before going to this one is very easy. Although looking 13.
सर
हाँ.
देखो वो डी मॉर्गन रूल का बताइए दोबारा क्या था वो
De Morgan's rule is if you take complement of their union, okay, that will be complement of their intersection. Intersection of their complement.
यस
Complement of the union is intersection of the complements, and complement of the intersection will be union of their complement. This is De Morgan's law. You remember this way, whenever inside union, for this case it will be outside intersection. It will be intersection. If it is intersection, here it will be union. That way you can remember. Okay. Here union, so it will be intersection. That way you can remember. Intersection, it will be union here. That way you can remember. Okay. See. A computer consulting firm presently has bid out on 3 projects. So 3 projects. AI is awarded project I for I equal to 1 to 3. And suppose PA1, PA2, PA3 intersection of A1, A2, A1, A3, A2, A3 and all intersection A1, A2, A3 are given. Express in word each of the following events and compute the probability of each event. So all the probability of this simple means each of the event A1, A2, A3 is given, their intersection 2 at a time, 3 at a time are given. Now we have to find some probability and also what are the event that we have to express in words. So what is the meaning of union? Union means at least one occurs. Correct or not? And intersection means both are occurs. Intersection means both the things are happen. Union means at least one happens. Or you can think a union means or. Intersection means both and. Union is or, intersection is and. That way also you can think. So A1 union A2. That means awarded project is either 1 or 2. So at least one of the project awarded from 1 and 2. That thing is A1 union A2. So awarded project is either 1 or 2. Those things are written here, A1 union A2. So awarded project 1 or 2 or both. Means at least one project of 1 and 2 is awarded. That way you can think. So A1 union A2. So PA1 plus PA2 minus PA1 intersection A2, all values are given in the questions. Then you will find it. Next one is A1 dash intersection A2 dash. A1 dash means project 1 not awarded. A2 dash means project 2 not awarded. Intersection means both A1 and A2 are not awarded. Correct or not? Event B, A1 dash intersection A2 dash. Both project A1 and A2 are not awarded. Are you getting the point? Probability you can find it easily. So awarded project neither 1 not 2. So or both A1 A2 not awarded. So A1 dash intersection A2 dash. So but PA1, PA2 those things are given. So what we are doing? We are applying De Morgan's rule. A1 dash intersection A2 dash is A1 union A2 whole dash. So then probability of A complement is 1 minus P. So 1 minus P of A1 union A2. A1 union A2 is already defined. So 1 minus 0.36, that is 0.64. Part 1, part B clear?
Yes.
And every time this type of one question in the mid-sem exam. Okay. So solve this type of questions from here, also from any other books. Question 13, 12, then 17 maybe theoretical things, 16, solve this type of question. Then A1 union, A2 union, A3. So at least one of the project is awarded out of 1, 2 and 3. A1, A1 that you can find by addition rule formula for 3 event. See here. I will share this PDF, but first you practice the things. Okay.
Okay,
Awarded
sir.
project at least one or two or three. So P of A1 unit is PA1, PA2, PA3
Okay,
minus
sir.
intersection of 2 at a time plus intersection of 3 at a time. Then probabilities are good. A1 dash intersection A2 dash intersection A3 dash means A1 not awarded and A2 not awarded and A3 not awarded. So none of these project awarded. Awarded none of these project 1, 2, 3. Here D Morgan's rule for 3 event. A1 dash intersection A2 dash intersection A3 dash. So that will be nothing but A1 union A2 union A3 whole dash. Then 1 minus probability of this by complementation rule. That way it is fine. Part D is okay. Part E, A1 dash intersection A2 dash intersection A3 means A1 not awarded and A2 not awarded, but A3 awarded. So awarded project 3, but neither 1 not 2. Or you can write awarded project 3, but 1 and 2 are not awarded. That way also you can write. How it is find? A1 dash intersection A2 dash intersection A3. So only this part we are using De Morgan's rule. A1 union A2 dash intersection A3. Then it is written this way. A1 dash intersection A2 dash intersection A3 is, we are writing this set. After that A intersection B complement is PA minus P of A intersection B. We have applied that formula. A intersection B complement is PA minus P of A intersection B. So P of A3 minus probability of intersection of these two sets. A1 and A3 intersection A3. That way it is done. Then some calculations are done. Okay. So solve this type of question. Solve this type of questions.
Okay, sir.
Suppose 16. What is 16? Sorry. An individual is presented with three different glasses of cola labeled C, D, and P. An individual is presented with three different glasses of cola labeled C, D, and P. He is asked to taste all three and then list them in order of preference. Means what is first preference, what is second, what is third. He have to he is asked to all three test all three and list them in order of preference. Suppose that the same cola has actually been put into all three glasses. Okay, what are the simple events in the ranking experiment? So how we can write? If C is the first preference. That case, what are the choices in second and third? DP or PD? Correct or not? So outcomes will be CDP. Just 1 minute. হ্যাঁ ক্লাসে আছি। So CPD. So if C is the first one, second one will be either PD or DP. If P is in the first position, CD remainings are PCD, PDC. If D is in the first position, there is C and P, DCP, DPC. So these are the list. Is this okay? Hello?
Yes, sir.
Okay, sir.
Now, what are the simple events in this ranking experiment? That is okay. And what probability would you assign to each one? What will be the probability of each of the simple event? 6 outcomes. So each of the simple event probability will be 1 by 6. Because actually same cola was filled in the C, D and P. All the glasses have actually same cola. That's why they are equally likely. So we will assign equal probability each of them. So 6 simple events. So each of the simple event probability is 1 by 6. Is that okay?
Yes, sir.
What is the probability that C is ranked first?
1 by
C
3.
will be the first position. So only 2 outcomes, CPD, CDP. So 2 by 6. See this question also answer here. So probability of each outcome 1 by 6 because same cola was given in each of the glasses. That's why each of the simple events are equally likely. Since equally likely, we can assign same probability each of the given. So total 6 outcomes, same probability. That means each of them will be 1 by 6. Why it is 1 by 6 clear?
Yes, sir.
Then probability of C rank first. C will be in the first position, CDP, CPD. Each of these are disjoint event. So 1 by 6, 1 by 6, 2 by 6, that is 1/3. Then C ranked first, D ranked last. So C will be in the first position, D will be in the last position. So middle one, obviously it is P. So CPD, 1 by 6. Is this okay?
Yes, sir.
Okay. These are the things in 2.1 and 2.2. So sample space, events, axiomatic definition, then addition rule, some useful properties are done in 2.2. Then we will start conditional probability, although in this note maybe written also, but here also it is given. Next it is conditional probability. Have you studied earlier conditional probability?
No, sir.
Okay. So A and B are any two events connected to a given random experiment E. So the conditional probability of the event A on the hypothesis that the event B has occurred denoted by P of A given B. What is P of A given B? P of A intersection by P of B, provided PB not equal to 0. See, forget about whatever written. Suppose this is the formula. P of A intersection B by P of B. Obviously, denominator will be non-zero. That's why it is required P of B not equal to 0. So, A and B two event which are connected with a random experiment B. So, what is the meaning of P of A given B. P of A given B means the event B has already occurred. Assuming the event B has occurred, we will find the probability of A. That is P of A given B. This is written as A given B. We read this way. This is A given B. So B is given. That means B is already occurred. Then we will find the probability of A. That is the meaning of P of A given A. Is that okay? Hello?
Yes, sir.
That means you can think new
Yes, sir.
sample. You can think sample space as B. See. So B has already occurred. Then we are finding assuming A. Means inside B we will find the probability of A. So if we consider thing for just for understanding, suppose finite number of elements. Okay. So what will be that probability? Inside B we will find the probability of A. So that means number of element in A intersection B divided by number of element in B. Correct or not? Now n of A intersection B divided by total number element in S, n of S divided by n of B divided by n of S, which is nothing but P of A intersection B divided by P of B. So since PB is in the denominator, that's why PB will be non-zero. So P of A given B, so A given B means the event B has already occurred, then we will find the probability of A. That is the meaning of A given B. A given B, so B is given, not A given. Okay, so whatever is after this bar, that things is already given. Assuming that we will finding probability of this, that thing is denoted by P of A given B. That is nothing but P of A intersection B divided by P of B. So since PB is in the denominator, so we have to assume in the condition P of B is not equal to 0. Means that is non-empty event. It cannot be empty event. So that thing is written here. P of A given B is P of A intersection B by P of B. It is okay. Similarly, conditional probability of B given A. That means A is already occurred. So P of A not equal to 0. So P of B given A, probability of intersection of these two events divided by P of A. So P of A given B, so whatever is after the bar, that will be in the denominator, and in the numerator it will be probability of their intersection. See, B given A, so probability of B intersection A divided by P of A. So formula is okay?
Yes, sir. Yes, sir.
Now one question is done here. Rolling a paired dice. A and B are the events, even phase and multiple of 3. So A is the even phase and B is the multiple of 3. Then find P of A given B, B given A. A is even phase. What are the even outcomes? 2, 4, 6. So probability of A is 3 by 6. B is multiple of 3. Multiple of 3. So B is 3, 6. So P of B is 2 by 6. Now for calculating A given B, we require A intersection B. Probability of A intersection B, that's why we are calculating A intersection B. So 2, 4, 6, 3, 6. Common is 6. So P of A intersection B is 1 by 6. P of A given B. By the formula P of A intersection B by P of B. A intersection B is 1 by 6. P of B is 2 by 6. So half. B given A, B intersection A by PA. 1 by 6, P of A is 3 by 6. That way it is done. So finding conditional probability is clear.
Yes, sir.
Yes, sir.
Now one thing I am telling. So A given B means inside B we will find the probability of A. See, here we have given P of A intersection B is half. See, B contains in B. So P of A given means B occur, then we will find the probability of B. So P of A given B. So we can think this way, new sample space is B. So B is 3, 6. A given B means inside B, what are the elements of A? A is even phase. So inside B, for A only 6 is there. So that's why probability is 1 by 2. That way also you can think. Or B given A. So B given A is even phase 2, 4, 6. B is multiple of 3, 3, 6. So B given A means inside A probability of B. So A contains how many elements? 3. Inside A how many elements of B are there? Only one element. That's why probability is 1 by 3. So P of B given A is 1 by 3. See here, B given A is 1 by 3. That way you can think also. So conditional probability is clear?
Yes, sir.
Yes, sir.
So basically P of A given B is P of A intersection B, whatever is given that will be here, provided P of B not equal to 0. Similarly, P of B given A is P of B intersection A by PA, provided P of A not equal to 0. One thing, P of A given B is nothing but inside B the probability of finding the probability of A. That means B is already definitely occur, then we will find the probability of A. That is the conditional probability. One condition is given. So what is the condition? A given B means B already occurs. So that thing is given. That is our condition. Okay, that way one can think. Now some one results are given. Multiplication rule. What is that? See, from first one, what will be P of A intersection B? P of B into P of A given B, or P of from this P of B intersection A is PA into P of B given A. That thing is called multiplication rule. If A and B are events in a sample spaces, P of A not equal to 0 and P of B not equal to 0. That case, P of A intersection B is PA into P of B given A, or P of B into P of A given B. This is called multiplication rule. Multiplication rule is okay?
Yes, sir.
Similarly, for 3 events, it is given. So just from the definition, it is coming. P of A intersection B is PA into P of B given A. For 3 events, how we can write P of A intersection B intersection C? See it carefully how I am writing what is the formula for multiplication rule 3 events. A intersection B intersection C. So you write probability of the first event, that is P of A. Then probability of the next event given previous event. Next one is B. So before that it is A. So P of B given A. Then next event, next is C. So P of C given whatever event is in the previous. So previous it is A intersection B. So this is multiplication rule for 3. So probability of the first event, then probability of the second event, whatever is in the previous. Previous is A, so P of B given A. The next one P of C, probability of C given, whatever portion is in the previous, that we will write. That is P of C given A intersection B. This is multiplication rule for 3 events. And obviously provided P of A not equal to 0, P of A intersection B not equal to 0. Otherwise we cannot write that. For 3 events rule is clear.
Yes, sir.
Proof is very simple. You start from right hand side. See, if we write P of A, that is okay. P of B given A will be P of B intersection A divided by PA. This one will be P of C intersection A intersection B divided by P of A intersection B. B intersection A intersection B same, cancel, PA cancel. So P of A intersection B intersection C. That thing is written here. We have started from right hand side. PA, P of B given A, P of C given A intersection B. So P of B given A is probability of their intersection divided by whatever after the bar. So P of B intersection A divided by P of A. Here probability of their intersection, P of C intersection B divided by P of A intersection B. Then we rewrite the thing because A intersection B intersection same. That way we are getting. Is this clear?
Yes, sir.
Now what is the rule for any number of events? Suppose n events are there. So same way we will write probability of A1 intersection A2, that way up to AN. What will be that? First probability of the first one, P of A1. Then what is next one? Next one given previous, A2 given A1. Next it is A3. Before A3, what is given? A1 intersection A2. A3 given A1 intersection A2. That way, what will be the last one product? AN given A1 intersection A2, that way up to AN minus 1. That is multiplication rule for n number of events. Is this okay? Hello?
Yes, sir.
And yes, some of you join. I am sending this one in the WhatsApp group. That will be better. N events it is given. At a time we will solve the question. Then one thing is there, total laws of probability. So total laws of probability, Bayes theorem, and independent dependent of events. So what is total laws of probability? Multiplication rule. Total laws of probability is if A1, A2, AK are mutually exclusive and exhaustive set of events, then for any event B, probability of B can be obtained by this formula. A1, A2, AK mutually exclusive and exhaustive set of events. That case for any event B, probability of B will be P of B given A1 into P1 plus P of B given A2 into P of A2, that way up to P of B given AK into P of AK. That means If we know all probability of each of the events A1, A2, AK, and if we know probability of big event AI, then probability of B can be obtained by this formula. This is called total loss of probability. So proof is very simple. So A1, A2, AK are mutually exclusive and exhaustive set of events. A1 total loss of probability. So I am not writing the statements. A1, A2, AK mutually exclusive. What is the meaning of that? Mutually exclusive means they are disjoint.
Intersection 0.
That means if you take any two different, their intersection is empty. AI intersection AJ equal to
Fine.
I for I not equal to J. Then exhaustive. This collection AK. What is the exhaustive meaning?
Union sample space आएगा.
Union sample space. So union of AI, I from 1 to K, that is the sample space. Okay. Now we have to find probability of B. So how we can write B? B we can think B intersection S. S is the universal set means sample space here. So B intersection union of I from 1 to K, we are putting the set S AI. Then by set theory it will be I from 1 to K B intersection AI. Is this okay?
Yes, sir.
Now what will be probability of B? Probability of B will be probability of this set, union of this set. But one thing, B intersection AI, this collection also mutually exclusive. Why it is mutually exclusive? If we take two different, see, AI intersection B intersection AJ intersection B. What will be this? AI intersection AJ intersection B. B is the common. So AI intersection AJ, that is phi. Before I not equal to this, phi intersection B equal to phi for I not equal to J. That's why that collection also mutually exclusive. So P of B will be P of union of this set. So I am not writing that thing. See here, AI are mutually exclusive, so their intersection is empty for I not equal to J. AI are exhaustive, union of AI equal to S. Then B will be B intersection S. S is this set. Then by set theory, union of I from 1 to K, AI intersection B. Now AI intersection B, that collection also mutually exclusive. For I not equal to J, it is calculated AI intersection B intersection AJ intersection B. So AI intersection AJ, that is phi, phi intersection B is phi. So that collection is mutually exclusive. By axiom 3, P of B is P of union of this set. But by axiom 3, that will be P of A1 intersection B, that way up to P of AK intersection B. Up to this line it is okay? Hello.
Yes, sir.
Now, what is A1 intersection B? By multiplication rule. So P of B given A1 into P of A1. Then P of B given A2 into P of A2. That way up to P of B given AK into P of AK. A1 intersection B is same as B intersection A1. So P of B given A1 into P of A1. That way up to P of B given AK into AK. So that's why I from 1 to k, P of AI, P of B given AI into P of AI. That thing is called total loss of probability. So why total loss of probability? See, whatever collection A1, A2, AK, that cover the whole things, total things. And if we know the probability of those events and B given AI, then we can find it. The total probability of B by using this formula. This is total loss of probability. So this formula is okay. हेलो,
सर इसका एक बार फिर से यूज बता दीजिए, क्या यूज होगा?
हाँ क्वेश्चन है ना, इसके ऊपर हम लोग बहुत सारा क्वेश्चन सॉल्व करेंगे. टोटल लॉज ऑफ प्रोबेबिलिटी बेस्ड थियरम. आई थिंक हैव यू स्टडीड this type of formula? Have you studied Bayes theorem earlier?
No, sir.
Okay. Okay, next class I will solve questions on this and Bayes theorem. So what is Bayes theorem?
Okay, sir.
Same assumption. A1, A2 up to AK mutually exclusive and exhaustive set of events. Okay. That here total loss of probability, we are finding probability of any event B, P of B is given by this formula. So then they are, for Bayes theorem, what is the thing? A1, A2 same condition, A1, A2, AK are collection of K mutually exclusive and exhaustive set of events, and we know the prior probability is P of AI, that we know. Then for any other event, suppose P of B greater than 0, then AJ given B. What will be probability of AJ given B? Probability of AJ by conditional probability definition, P of AJ intersection B divided by P of B. Now here probability of B given AJ into P of AJ. So you can P of AJ into P of B given AJ. And P of B by total loss of probability, this summation. So that is called Bayes theorem. Basically, if we know the P of AI and P of B given AI, then by using this formula, we can easily calculate P of AJ given B. That is Bayes theorem. Anyway, next class I will again discuss total loss of probability. So this is the, and we will solve questions on that. Okay. After that, dependent, independent of events. Up to this it is okay?
Yes, sir.
Okay. And how many of you are attending the class? 75.